Howdy students. In this video I'm going to talk about the single most important data set in climate science, the surface thermometer record. This is the data set that we most rely on to tell us the climate is warming. It's based on technology that's hundreds of years old, the liquid in glass thermometer that I'm sure you're familiar with. In the last video we talked about how you only need about 100 thermometers spread around the globe to make a measurement of the global temperature anomaly. Since the middle of the 19th century, we've had sufficient coverage so we can calculate a temperature anomaly over time. Here's what it looks like. It doesn't take a rocket science to see that the Earth is warming. The warming between the late 19th century and 2021 was 1.1 degrees Celsius. This is a bit higher than the value in the textbook because it's a more recent number, but I will accept either value on a test. Make sure you know this. Now, this doesn't sound like a lot of warming, but when we get to Chapter 9, we'll see that it is, and that predictions for the 21st century are for several times this much warming. We also are not talking here about why it's warming. In Chapter 7, we'll talk about attribution, and I'll explain why we're so confident that humans are the dominant driver of this warming. Now, this figure shows the distribution of warming across the globe. Virtually the entire globe is warming, hence the global part of global warming. But the warming has not been uniform. We see that land areas warm more than the ocean, mainly due to the higher heat capacity of water, and that the northern hemisphere has warmed more than the southern hemisphere, and that the fastest warming place in the globe is the Arctic. It's warming much faster in the Antarctic. Given that most people live on land and in the northern hemisphere, this means that people have and will continue to experience quite a bit more warming than the global average. Assembling the surface temperature record is no easy feat. There are lots of known issues with the data that need to be accounted for. As an example of the kinds of issues, let me tell you about what scientists call the urban heat island effect. As we talked about in the previous video, regions that have a lot of urban structures, buildings, parking lots, concrete, tend to be warmer than regions covered by vegetation. Why is this important for the surface temperature record? This is a satellite image of College Station, Texas from 1984. Imagine that we put the thermometer in a rural area like right here. College Station has grown rapidly in the years since. So in 2016, the thermometer is now in a suburb with a lot more concrete around it. Because of this growth of the city around the thermometer, the station will show a warming trend even in the absence of any actual trend in the large-scale climate. The scientists that produce surface thermometer records know about this and make adjustments for this and other issues in the data. Many of the groups have documented the adjustments they make. This is a plot of the raw data for Love Field in Dallas. First, the data are filtered to remove obviously wrong data, like this month that's 15 degrees below nearby months. After this is done, there's a large, clear warming signal in the data. However, we need to figure out if some of this warming is spurious from things like the urban heat island effect. To determine that, scientists compare this station to nearby stations. This plot shows the temperature of this station minus the temperature from nearby stations. We expect no trend since nearby stations should have similar anomalies, as we discussed in the last video. However, we see a clear positive trend. The positive trend here means that this station is warming faster than nearby stations. If we investigate more closely, we find that most of the trend is caused by discrete jumps in the data set, places where the station's temperature suddenly jumps up or down. These temperature changes, which are not reflected in nearby stations, are probably due to a problem with this station. So these are not changes in the climate and should be adjusted out. After adjusting for all of the issues, this is what they come up with. The red line is the temperature time series for this station, and the blue line is the average of nearby stations. As you can see, they agree well, which is what you would expect. In this case, by the way, the adjustments to the data reduce the trend from 1.8 degrees per century in raw data to 0.7 degrees per century in the adjusted data. So to get the global average record I showed earlier, they do that adjustment process for thousands of stations all around the globe, and then they average them, and then this is what they get. Now, if you talk to your skeptical friends, they might claim that these adjustments mean the data are not reliable. How should you respond? So, first of all, anyone who says that, you should punch them in the face, like hard. What? Not at all? Okay, I'm being told that Texas A&M's policy is not to punch anybody in the face. Even if they go to UT? No? Okay, that's a no. All right, so if punching is out, and it is, how might you respond to your friends? So here are a few things I would tell them. First, several independent groups have all produced estimates of the surface thermometer record using independent algorithms for adjusting the data. Here's a plot. The different groups all produce nearly identical results. As we talked about in Chapter 1, multiple replications of a scientific result should give you confidence in that result, because it is very unlikely that all the groups would have made identical errors. In addition, the adjustments aren't that important. This plot shows that if you don't do any adjustments, you just average the raw data, you get the dotted line. It's not a very different result. The reason is that while adjustments can be large for any particular station, they tend to cancel. So stations that are warming too much cancel stations that are warming too little. And in the end, they don't actually matter that much. Now, some people might argue that scientists aren't dumb, but they're part of a giant conspiracy. First, that would be pretty hard to pull off. I showed before that several groups, comprising hundreds of scientists, have all produced almost identical estimates. A conspiracy would require coordination among all of these people. It's hard to believe that everybody would go along with such a conspiracy. Second, many of these groups put their code and raw data online, so you can actually look at every step they make to convert the raw measurements into the processed global average values. People have gone through the code and independently verified that the code does exactly what the groups say it does. There is no secret adjustments to the data to make the data show warming. So this should give you some confidence in the result that the climate is warming. We have multiple replications of this record, and even if we don't adjust the data, you still get about the same answer. In the end, the surface thermometer record is the most studied, and it sets the foundation for our understanding of climate change. However, this point is so important that we'd like even more data to verify that the planet is warming. In the next video, I'll talk about several completely independent data sets that confirm the warming we see in this record. And now, your moment of dog.